Hello everyone, in this video we will discuss the concept of highest common factor or HCF. Let's get started. Before we get into the concept of HCF, let's first discuss about factors. What are factors? Factors are numbers which we can multiply together to get another number. For example, if you have a number, let's say 10 is nothing but 5 multiplied by 2, or I can say 5 and 2 are factors of 10. Similarly, 8 is nothing but 4 multiplied by 2. So 4 and 2 are called factors of 8. A given number can have many factors. For example, if you consider the number 6, which are the factors of number 6? It is 1, 2, 3 and 6. See, the number 6, you can represent it as 6 is equal to 3 multiplied by 2, or you can say 6 is equal to 1 multiplied by 6. Correct? There are different ways in which you can represent a number. So, a number can have many factors. Here the number 6 has 4 factors. Similarly, if you consider the number 12, how can you write the number 12? 12 is nothing but 4 multiplied by 3, or you can write 12 as 6 multiplied by 2, or again 12 you can write it as 12 multiplied by 1. So, which are the factors of the number 12? The factors of number 12 are 1, 2, 3, 4, 6 and 12. Now that we have discussed about factors, let us understand what is common factors. What are the factors of 6? The factors of 6 are 1, 2, 3 and 6. Similarly, what are the factors of 12? The factors of 12 are 1, 2, 3, 4, 6 and 12. Out of these factors, there are some factors which are common to both 6 and 12. Like for example, 1 is common to both the numbers. Similarly, 2 is common to both the numbers. Again, 3 is also common to both the numbers, and 6 is also common to both the numbers. That is, these factors are common to both 6 and 12. So, these factors are called as common factors. The factors which are common to a given set of numbers are called as common factors. Now then, what will be the highest common factor be? The highest common factor will be the factor which is common to the given numbers and also is the highest possible factor. In this case, when I am considering 6 and 12, which is the highest common factor of 6 and 12? It is 6. 6 is the highest factor that is common to both the numbers, or I can say HCF of 6 and 12 is equal to 6. Any given number will have factors, and when we write down the factors of numbers, there will be some factors which will be common to the numbers that we are considering, and the highest of that is called as the highest common factor. You can find HCF for 2 numbers or 3 numbers or 4 numbers. Here we have found out the HCF of 2 numbers. We have found out what is the HCF of 6 and 12. Sometimes they will give you 3 numbers and you will have to find the HCF of the 3 numbers. In that case, what will you do? You will have to just write down the factors of the 3 numbers and then identify which are the common factors and find out the highest common factor. This method of finding the HCF is time consuming, because for each number you will have to write down which are the factors. Here the number is very small, 6 and 12. So you are able to find out the factors easily. Let's say you have a number 1008. It's difficult to write down the factors like this, right? In such cases, there is a different approach in which you can find out the highest common factor. Let's look into that approach as well. Let us consider 2 numbers here. Let us find out the highest common factor of 36 and 18. Let us try to find out what is the highest common factor of these 2 numbers. So, one way of finding out the highest common factor of the 2 numbers is by prime factorization. Take each number separately, take 36 and keep dividing this 36 by the lowest possible prime factor. So, which is the lowest possible prime factor which will divide 36? That is nothing but 2. What is 36 divided by 2? 36 divided by 2 is 18. Again divided by the lowest possible prime factor. So, you have 2. 18 divided by 2 is 9. Again divided by the lowest possible prime factor. Basically, keep dividing the number by the lowest possible prime factor till you get the answer as 1. Can I do 9 divided by 2? No, 9 is not divisible by 2. So, I will go with the next smallest prime factor, which is 3. What is 9 divided by 3? 9 divided by 3 is 3. Again, I will divide this by 3. 3 divided by 3 is 1. So I can stop at this point, or I can represent 36 as, similarly, let's factorize 18. So I have 18 divided by 2 is 9. Then again 9 divided by 3 because is equal to 3. 3 divided by 3 is equal to 1. Or I can represent 18 as 2 multiplied by 3 multiplied by 3. Among these factors here that I have written, see which are the ones which are common to both the given numbers. This 3 is common to both the numbers, right? 3 is there appearing once here as well. Similarly, there is 1 2 that is common to both. There is only 1 2 which is there as a factor of 18. For 36 there are 2 2's. So this 2 is not there in 18, so I will not consider that. I am just looking at the numbers which are common to both the given numbers 36 and 18. Similarly, here 3 is there, here also 3 is there. Or which are the factors which are common to both the given numbers? It is nothing but 2 multiplied by 3 multiplied by 3. 2, 3 and 3, these are the numbers which are common to both the given numbers, or I can say the highest common factor of both the given numbers is nothing but 2 multiplied by 3 multiplied by 3, which is equal to 18. So the HCF of 36 and 18 is equal to 18. That is your correct answer. So instead of writing down the factors and then solving, this is another way of finding out the HCF. Other than the two methods that we discussed, there is also a third way to find out the HCF of two given numbers. Let us understand that as well. Let us assume we have to find out the HCF of 54 and 16. This method is called as a division method, and here what we do is, when you are asked to find out the HCF of two numbers, you will divide the bigger number by the smaller number. So here what will I do? I will divide 54 divided by 16. Now what will be the quotient here? 16 3s are 48. So 3 will come on top and this will be 48, and 54 minus 48 is equal to 6. I should not stop here. I should continue the division and I should keep doing these steps till I get the remainder as 0. So here I am getting 54 minus 48 is equal to 6. At this point what I do is, I take this divisor of the previous step, right? That will come here, and then that will become the dividend. And now I will do 16 divided by 6. Now what is the quotient of 16 divided by 6? That will be 2. 6 2s are 12. So I put that 12 here, and what is 16 minus 12? 16 minus 12 is 4. And again the next step, I have to continue, right? Here my remainder is not 0, so I again continue to the next step, and this 6 will come here, and I will have to do 6 divided by 4. Now what is 6 divided by 4? 1 4s are 4. And what is 6 minus 4? 6 minus 4 is 2. Again my remainder is not 0, so again I will take this 4, bring it here, and I will do 4 divided by 2. When I do 4 divided by 2, what will come here? This will be 2. 2 2s are 4, and 4 minus 4, that is equal to 0. So I stop at this point when I get the remainder is equal to 0. When I get the remainder is equal to 0, I stop at that point, and what will be the HCF of these two numbers? The HCF of these two numbers will be 2. That is, the step where I get the remainder as 0, in that step whatever was the divisor, that will be my HCF of the two given numbers. So the HCF of 54 and 16 here is nothing but 2. That's the answer that we are looking for. Let us just cross check this with the previous question that we solved. Previously we found out that HCF of 36 and 18 was 2. Let us just cross check that with this division method also. So I am doing 36 divided by 18, and what will be 36 divided by 18? 18 2s are 36, and my remainder is 0. So I have only one step here, and I am stopping here directly. So this is the case where the remainder is 0. In this step, which is my divisor is 18. So obviously the HCF of 36 and 18 is going to be 18 only. Correct? I hope this method is also clear to you. Alternatively, we can also find the HCF of given numbers using a similar method that we use to find out LCMs. Let us learn that method as well. So let us consider three numbers to understand this. Let us try to find out the HCF of 12, 20 and 40. In the long division method, you will write all the numbers, that is 12, 20 and 40 simultaneously, and try to divide these three numbers by the lowest possible prime factor, which will divide all of these three numbers equally. In this case, I am looking at 12, 20 and 40. What is the lowest prime factor that will divide all of these three numbers exactly? It is nothing but 2. I am dividing all of these numbers by 2 and I get 6, 10 and 20. Again, which is the next lowest possible prime factor which can divide all of these three numbers? That is nothing but 2 again. So, you will get 3, 5 and 10. At this point, can I find out a prime factor which will divide all of these three numbers equally? No, I am unable to find out a prime factor which will divide 3, 5 and 10 exactly. When we were doing the LCM at this point also, we will continue because we will look at a prime factor which can divide 5 and 10 exactly, but that's not how you do it when it comes to HCF. While finding the HCF, you have to stop at this point, and the HCF that you are looking for is nothing but 2 multiplied by 2, that is equal to 4. So, the HCF of 12, 20 and 40 is 4. So, the HCF will be the product of the divisors. In this case, it will be 2 multiplied by 2, which is equal to 4. Now, let us understand this better by trying to find out the HCF of 36 and 18, the same question that we solved in the beginning using this method. So, when we divide 36 and 18 by 2, we will get 18 and 9. Similarly, in 18 and 9, 3 is a least common factor which can divide these two numbers. So, you will have 3 divide by 3 and we will get 6 and 3. Again, at this point, again 3 will divide these two numbers, and in the last step we will get 2, 1. At this point we stop. So, what will be your HCF? Your HCF will be the product of the divisors in each step, that is 2 multiplied by 3 multiplied by 3. So, the HCF of 36 and 18 is 18. We are getting the same answer again. I hope this method is also clear to all of you. So, you can choose any method depending upon your convenience while solving questions from HCF. Now, let's look at a question from this topic. Find the largest number that divides 92 and 74, leaving 2 as the remainder. Let us consider a number 37 and divide it by 18. When I do 37 divided by 18, what is the answer that I get? I get 18 2s are 36. So, I get 2 as my quotient and 1 as my remainder. So, whenever I divide 37 by 18, I get the remainder as 1. Correct? Now, if I want the remainder to be 0, when I divide 37 by 18, I am getting remainder 1. If the remainder has to be 0, then here instead of 37, what should come? It should be 36. That is, this 37 minus 1 will give me the number which if I divide by 18, I will get the remainder as 0. Similarly, here when I am dividing 92 by some number x, I am getting the remainder as 2. If I have to get the remainder as 0, then the number that I have to divide by x is nothing but 92 minus 2, or if I divide 90 by x, the remainder would be 0. Similarly, when I am dividing 74 by x, I am getting a remainder as 2. So, if I have to get the remainder as 0 when I am dividing a number by x, then what should that number be? It should be nothing but 74 minus 2. When I divide 74 minus 2 by x, the remainder that I get will be equal to 0. I have to find out the highest or the largest number that will divide 92 and 74, leaving 2 as the remainder. Or all I have to do is, I have to find out the HCF of this 92 minus 2. 92 minus 2 and 74 minus 2. Why 92 minus 2 and 74 minus 2? If the number was, instead of being 92, if the number was 92 minus 2, or that is 90, then x would have divided it completely and the remainder would be 0. Similarly, if the number here was 72, then when I do 72 by x, again the remainder would be 0. So if I find out the HCF of 90 and 72, I will get the number that I am looking for. What will be the HCF of 90 and 72? Let us do it using the long division method. You can use any method that you prefer, whichever is comfortable to you. Please use that method. So I will have here 2 will go in both of the numbers, lowest prime factor that I can use. So here I will have 45 and here it will be 36. I can divide both of these by 3 and this will be 15 and this will become 12. Again 3 will go in both the numbers. This will be 5 and this will be 4. At this point between 5 and 4, I am not able to find out a prime factor that will divide both of these numbers. So what will be the HCF of 90 and 72? The HCF of 90 and 72 is nothing but 2 multiplied by 3 multiplied by 3, or 9 2s are 18. So the HCF of these two numbers is nothing but 18. So the answer that we are looking for here in this question is 18. Just try out 92 divided by 18, you will get a remainder 2. Similarly, 74 divided by 18, you will get a remainder 2. I hope it's clear. So if the rule to keep in mind is, whenever they are asking you to find out the largest number that will divide any two given numbers leaving a particular remainder, all you have to do is subtract those numbers from the remainder and find out the HCF of all those numbers, and you will get your answer. If you still have any doubts on this concept, please do let me know in the comments box and I'll be happy to get back to you. Thank you.